Fasten your seatbelts. Today is going to be another exciting day. We are going to put a bunch of stuff together. We're going to graph. We're going to do linear inequalities. And then we got to worry about less than, greater than, or the equal to's. So, hold on. It's going to be awesome. So, let's first start by checking whether an ordered pair, now not anymore just an x is a solution, but an ordered pair is a solution to this linear inequality. So what I'm going to do is plug in x, where I see an x, so negative 3 is my x value, plus 5 times y, which is 5, and less than or equal to 12. So 4 times negative 3 is negative 12, plus 25. And when I do negative 12 plus 25, I get 13. 13 is not less than or equal to 12, so part A, negative 35, is not a solution. It doesn't work when I plug it into the equation or inequality that I have. Now if I plug in 0, 2, 4 times 0 plus 5 times 2 less than or equal to 12. 4 times 0 is 0 plus 10 less than or equal to 12. And 10 is less than or equal to 12. So part B, yes. It is a solution. And 6, negative 8, last one, check that one. 4 times 6 plus 5 times negative 8 less than or equal to 12. 4 times 6 is 24 plus a negative 40. We want to check whether that is less than or equal to 12, and negative 16 is definitely less than 12. So part C, yes, it is a solution. So by checking, we plug in the numbers, we simplify each side and see if the inequality is true. So you're probably wondering, what is it going to look like? I'm buckled up, ready to go, and that was nothing new. Well, we're going to graph lines today, and then we're going to shade one side of the line. Notice here that we have a dotted line. With a dotted line, it's like an open circle. You're either going to have a less than sign or a greater than sign. These two signs mean dotted line. A solid line is going to result from when you have the or equal to, greater than or equal to, or less than or equal to. Then you're going to draw a solid line and shade one side of that solid line. So let's do some examples. Let's start with just an x, one variable for now. So we're going to graph the line. We're going to pretend it's x equals 2 for right now. And we know that it's going to be a solid line because it's or equal to. So a solid line at x equals 2. So I'm going to draw a solid line. That's the first part, right? Draw the line. Now, which side do I shade? Well, it's greater than. So I have to ask myself the question, where is x greater than or equal to 2? Right? Well, it's this side over here, right? These numbers, these x values here are bigger. So I'm going to shade in the side where x is greater than 2. Some people like to do it with highlighters. Some people like to do it with markers. Some people just like to scribble like I'm doing right now. It's kind of fun. And that's it. The next example, we want to do x is greater than negative 3. So it's going to be a dotted line. So I'll make note of that in my head, a dotted line at y equals negative 3. So it's horizontal. Maybe dotted or maybe dashed is a better word than dotted. But at negative 3, I'm going to put a dashed or dotted line. Now I have to ask myself, where is y greater than negative 3? Well, here comes the highlighter. Y is greater than, y is bigger up here. So I'm going to shade everything above my dotted line. Highlighters can be fun too. And now, finally today, let's work on some that aren't quite so easy, that have two variables. So we got to solve for y. We want to get y by itself. So we have to do some little work on the side to get y by itself. So I'm going to move x over. So I get negative y less than or equal to negative x plus 2 divided by negative 1. And then I have to remember, because I divided by negative, switch the sign. Negative x divided by negative 1 is just x plus, and then 2 divided by negative 1 is negative 2. So now I have to graph this inequality. In order to do that, I need some points to graph. Right? So let's make an xy chart. Plug in an x. Let's do 0. 0 plus negative 2 is negative 2. Let's do 2. 2 plus negative 2 is 0. Let's do 4. 4 plus negative 2 is 2. So I'll plot the point 0, negative 2, 2, 0, and 4, 2. So then I can draw a line. And that line is going to be a solid because it's or equal to. So it's going to be a solid line. You should make sure you use a ruler when you draw on these lines. Now, what side do I shade? Well, a couple ways to think about it, and maybe it's good to check both ways. But it's a greater than, so I'm going to shade above the line, right? So this side up here is above the line, so I'm going to shade in everything above the line. Another way to think of it is, I want to take the point 0, 0. I'm pretty sure that 0, 0 is on this side of the line. And I think I shade that side. So I want to know, do I really shade 0, 0? What I'm going to do is take my equation, and I'm going to see if 0, 0 is a solution. So 0 is greater than or equal to 0 minus or plus a negative 2. Is 0 greater than negative 2? Yes, it is. It's a solution, so I shaded the right side. So you can do that. You can do a greater than, do above the line, less than, below the line. You can also plug it in and check. Is a number on this side of the line, pick a number that's not on the line, that's on one side of the line. Is it a solution? If it's a solution, you shade that side. If it's not a solution, you shade the other side. Okay, again with this one, we have to get y by itself. So let's subtract 3x from both sides. There's our line. Note to self, dotted line. We'll make a note right here so we don't forget. Dotted or dash line. We need some xy points. So let's plug in 0. If we plug in 0, we get 2. If we plug in negative 1, negative 3 times negative 1 is 3, plus 2 is 5. If we plug in positive 1, negative 3 times 1 is negative 3, plus 2, negative 1, 0, 2. So I'll plot those points. And I'm remembering right now that it's a dotted line. 1, negative 1. Now it's less than, so I think this side here is below, but I'm not quite sure. But I know 0, 0 is a nice number, and I know it's on this side of the line. So I want to see whether 0, 0 is a solution. I can plug it into this equation here, or this top one, either one. 3 times 0 plus 0, is that less than 2? Yes, it is, because 0 is less than 2. So that means I shade the bottom part, or kind of on the left hand side.